Okay, so again, let's look at some relationships. What is the relationship between the following molecules? This is a very typical kind of question that you get, so I'm trying to do a few of them for you so you kind of understand how I solve them. You may solve them the same way or you may have your own way. It doesn't matter, but you still need to know how to solve these problems. Okay. All right. So here are the two molecules where we have CH3 and then hydrogen coming out, CH3 going at the back, and then bromine, and then another one where we have hydrogen, CH2, Br, CH3 coming out, and then hydrogen going to the back. All right. So first of all, when you look at these two structures, you look at this carbon and see if it even has 4 different groups, and it does not have 4 different groups. It has 2 methyl groups, so it's not chiral. Okay, first of all, even though it's shown in 3D structure, it doesn't matter. Okay, it doesn't mean it has to be chiral. And here also same thing. If you're looking at this carbon here, since you have 2 hydrogens, this is also not chiral. So you have to focus on those 2 over here. If you look at the complete structure, the first one is 1, 2, 3 carbons, and so this is 2 bromo propane. The second one is 1, 2, 3. So this one is 1 bromo propane. So which means that these 2 are actually constitutional isomers. Okay, so just because they're drawn in a certain way, in a 3D way, doesn't really mean that they are actually supposed to be optically active, okay, in any way. All right, so that was one. Let's look at another one, okay, and now I want to take a Fischer projection, okay, and explain that also while we do this kind of a problem. So here we have this compound CH3, and you're asked to compare to this molecule, which is CH3 Cl H H Cl CH3. So then the first thing that you do is you draw them in 3D format, okay, so you kind of understand what they look like. And so the first one, okay, let me not draw it here, let me draw it down here. So the first one, okay, you draw the 2 carbons, okay, then the CH3 is going to the back, the chlorine is coming out, hydrogen is also coming out. All right, again here, the CH3 is going to the back, hydrogen is coming out, and then chlorine is also coming out. Okay, that's how you draw the first one. Second one, same thing, draw your 2 bonds first, and then the top one, which is the CH3, is going behind, and then the Cl is coming out, the H is coming out, and then for the one below, you have the hydrogen that's coming out, Cl coming out, and then CH3 that's actually going behind. Okay, that's what it looks like. Now if you look at these 2 molecules and compare the top one first. So if there is a mirror over here, they're both mirror images, okay, of each other. And that's only for the top carbon, okay, that they're actually mirror images of each other. Now you look at the bottom carbon, okay, and see what the relationship is between these 2. And you see that the CH3 is behind over here, okay, in the same location, but the H and the Cl have switched, okay, H and chlorine have switched. So if only one atom has switched or one group has switched, it means that they are going to be not mirror images. Therefore, these 2 compounds are going to be diastereomers, okay, because they don't have the same kind of stereochemistry. Okay, so just because the bottom one is switched, all right, if it was the same way, it would be a mirror image. Okay, and so in that case, if the top one is mirror image and the bottom one is a mirror image, then the relationship between the two molecules is going to be enantiomers, but because the top one is the same but the bottom one is different, then you have diastereomers. The last way you can confirm whether you have diastereomers or enantiomers is by figuring out the R and S, okay, of each of these. And so you can do that too, and if you want to do that really quick, let's do that. Okay, for this one, chlorine is coming out. This is the lower priority, and the hydrogen is the lowest priority. Okay, and this is coming out, so you need to keep this behind. Okay, so look from here, okay, at this molecule. So which means if you're looking over here, the Cl is first, this is second, and the CH3 is the third. Okay, so which means you're actually going from, again, okay, look through here. Okay, look from here. That's your beautiful eye. Okay, from here. So if you're looking from here, Cl is right here. So which means the next one is going down and the other one is going that way. All right, so which means this is S. Okay, and so then you can look at the mirror image. It should be the other way around. Okay, and so now you have Cl over here. Hydrogen is on the right hand side, so your beautiful eye should be over here. Okay, that's where you should be looking at it from. And then Cl going to this and then to that, that is actually R. All right, and so you can do the SR and then figure out if you have the same configuration or not. I will leave the bottom one to you, okay, and see if you can figure it out. All right, next molecule to look over, okay, is this one over here, where we have methyl group coming out, methyl group going in, and then a cyclobutane where you have two of the methyl groups coming out. Okay, so one of them have a plane of symmetry, the other one don't, and so this is considered to be like a geometric isomer because you also have like a cis and trans going on. So once you have this in a cyclic compound, these are considered to be diastereomers, cis and trans. Okay, that's what they would be. Okay.